Good morning. Thank you for joining us for our Cultivate Micro webinar series. We're on the last day, and I'm pleased to have with me Meena Sankaran, who's the CEO of KETOS. This is a company that we've partnered with in the horticulture market to supply water intelligence, basically. She's going to explain how they are monitoring the water and providing that as real-time data and how that can be useful to growers in our industry. I want to remind everybody that this webinar, as well as all the others, are being recorded and they will be posted. Typically, they're being posted within an hour of them closing on our website. So if you find something useful you want to share with somebody else, with a colleague, with another grower, they can get the link off of the site. We will send you all an email too, so you'll have access to that link shortly following. If you do have questions, we'll be taking those at the end, and there is a question tab in the GoToWebinar control panel that you've got on your screen. Just post it there, and I'll be asking those questions of Meena at the end. So without further ado, Meena Sankaran.
Thank you. Thanks, Kurt. Well, first off, thanks to the DRAM team, as well as Kurt, for having us over here. Really appreciate the opportunity. And excited to connect with all of you in a virtual world of us doing a webinar, which otherwise you would have seen me face-to-face talking and up on some sort of a conference here. But let me dive in. Today's topic is a very interesting one, something that I'm very passionate about, and I think most of you as growers or in the farming community care a lot deeply about when it comes to water. So just diving in, this is some of the accolades, and we've been recognized in the industry, and I'm really glad about how that's come about. And when I think about water and when KETOS' philosophy about water, it's always been looking at water efficiency, water quality, sort of like this yin and yang, two sides to water. So, you think about water efficiency, you think about leak detection. How do you really understand water quality in a more dynamic manner where you can actually take that data and do something about it, take an action around it? And ultimately, everyone is collecting so much data. It's not uncommon to have different types of sensors that you're in your farm or in your grow. So how do you make those more actionable versus having just a huge lake of all this data that you don't know how to make empower yourself or your own grower? So when you think about conventional monitoring, like what is monitoring today, and you realize you've got your lab tests, and I'm going to focus within the time constraint that we have today on water quality, and I'd be happy to dive into the other aspects of what we provide as well. But looking at water quality, you've got your handheld instruments. I think everyone is familiar with that. These have been around for decades. You've also got some selective online instruments now, but they are quite expensive when it comes to measuring just a single parameter. So you're thinking about, oh, I need a chlorine analyzer. You've got an entire chlorine analyzer online instrument that you've spent 15 grand or probably more. And then you are thinking, well, maybe I need to have something for nitrates, or I need to have something for silica, and you've gone and purchased another online monitor for that. So this can quickly add up for someone who's already operating on, say, a low margin or a grower and thinking about, well, how is this cutting into my costs? And so how am I going to manage my operational expense? How am I managing my capital budgets? And more so, you start reducing your frequency of testing unless it's absolutely required. And then your mindset becomes more around frequency of testing as a cost, which is unfortunate because if you can't act on what you don't measure. So if you did measure more, you could make more and better use of that data if you had that opportunity. So our goal with KETOS is, how do you break that norm? How do you shift that mindset of folks where frequency of testing is not a cost? And what if we can get you an autonomous instrumentation that you can leave outdoors or indoors if it's an indoor farming area, or if it's outdoors in a field ag, have that instrument be able to provide you data at your fingertips on your mobile phone, or if you're sitting at home, especially during current crisis and the pandemic, if certain people are not allowed to have restrictions about being on site, and they can actually remotely look at the data, what is that value to you? And being able to act on it. And if that can be really, really affordable without compromising on accuracy. So the trifecta is like your AAA, autonomous or automated, different terminology, accurate and affordable. How do you look at that triangle of achieving all three? Because the reason why people depend on labs is because it's accurate, it's precise, and the sensitivity is there, which is not being available in typical instrumentation. So let's figure out how we make that possible. So when you think about KETOS, we truly believe this is the future of water analytics, and we've gotten great validation from our customers. And so first thing is the automation. So you can think of us as an intersection of a lot of automation that we've brought into the industry, plus all of the communication that's required. You might be in the middle of nowhere. We have farmers in, say, Bakersfield, partial cell coverage, some no cell coverage. So how do you get that connectivity? Who's going to set up all that communication infrastructure? Farmer doesn't have the cycles to do that. The grower cannot invest in that kind of capital. So you have to think about not just the devices, but the connectivity infrastructure. And then how do they access the platform? One common complaint with a lot of when I'm talking to farmers or co-ops or the growers, the concern is like, well, I'm not a technologist, Meena. I have 7 tools I've been sold to in the last few years. You're bringing another 8th one. I agree there's value, but now I have 8 tools I have to manage, different logins, different passwords. I don't have the capital to go hire an IT guy. What do you suggest? And so the fundamental thing as technologists that we have to do is focus on how do we empower that farmer in an easier manner without all this overhead where technology becomes a burden for him and not necessarily an enabler. So in our mind, we think about it as how do we integrate this data? We don't need to be an all or nothing solution. A person can accommodate each of these pieces in small chunks that is comfortable to consume, acceptable to consume, and also at the end of the day, they can take all of that data and be able to have it in a single pane of glass. So let me dive in a little bit. Well, what is this system? So on your right-hand top corner, you see the system, and think of it as like the size of a microwave. And this is our KETOS shield, as in it's shielding you from water contaminants. It's a single system that you will, and I'll show you a picture of how it looks when it's deployed. And you essentially deploy it. It can be indoors, it can be outdoors. You are doing a continuous sample. So if you have a continuous stream of water, all you're doing is providing it like a 1/8 inch line and letting the water continuously stream through. And you're getting your environmental parameters, pH, conductivity, TDS, salinity, temperature, DO. It's about 6 or 7 parameters, I think, ORP2. And so once you have these 6 or 7 parameters, you're getting them every 60 seconds, about a minute by minute basis. You're not having to do anything about it. You're just getting that data on a continuous basis. There's no manual labor involved on that system for you to get that data. The second part is one of the most important or sort of differentiated features for us is you have a lot of instruments that do environmental parameters. Why would you care? And someone might ask, well, I don't need a minute by minute variance. If I get a couple of times a day, that's good enough. So it depends. Now, in some customers of ours, they don't have continuous water. So it's intermittent water. They get water about 4 to 5 hours a day, and that's okay. The biggest factor is there's a platform which is very intuitive and interactive to the user. So you can decide and schedule, I would like to run a nitrates test every hour, or I want a nitrates test once a day. One of our farmers wanted to make sure that we actually have phosphates, and that was something that was of top of mind, and specifically orthophosphates. The beauty of what the system is, it's very modular. Today, this single system can monitor about 20 plus parameters, and the parameters are constantly increasing. So when a farmer or another grower or even an industrial customer of ours is asking for a parameter, it takes us about 6 to 9 months to include that parameter into the system at no charge to the customer and at no additional charge, or you're not swapping a system. We come and do a maintenance visit and we upgrade the system, mostly on software front and also on the calibration front. Once we have that, you basically now have a menu, and think of it as a buffet. You have a buffet of parameters, and a customer can choose which parameters make more sense to me, and you schedule your testing based on your environment and your variance. So we do heavy metals, we do inorganics, we do nutrients, and we do environmental parameters. One of the most differentiated parameter, or I would say set of parameters that keeps us in the market very attractive for some of our clients is the nutrients as well as the heavy metals, because these are two very difficult things to do, especially the heavy metals. And so depending on what's of interest. So one of our farmer that really was concerned, he had a strong concern about boron. And based on the concentration of boron in the groundwater, he had to actually mix his surface water and groundwater. And this is for field ag, growing almonds, growing grapes. And then he also had, in certain cases, where he had to manage his nutrients based on how the nitrate reading was happening. So he was able to do this proactively versus figuring out post-crop quality, what that would have meant based on different water concentrations. So what is the value to you if you can understand arsenic, manganese, nitrates, boron, your chlorine, calcium, hardness, all of these parameters? And I'm sure the DRAM team can give you a list of, here's all the parameters that KETOS detects today for you to have that as a little cheat sheet. And another important part to remember is the sensitivity. It's not just important that you're able to measure. It's important that you're able to measure at the sensitivity that's meaningful to the grower. Otherwise, it doesn't really impact how they manage their nutrient load. So we measure all the way down to the lowest sensitivity possible, like at least at the billion level for 1 ppb. We don't go into trillion, but we do 1 ppb. So you can understand what is happening to my groundwater with arsenic. It's down to 1 ppb. Or can I understand my nitrates at a very low ppm level, not at 30 ppm? One of our farmers had a lot of Hawk instruments and he was not able to get the sensitivity he needed. The second problem was his Hawk instruments also, they were all optical based in a way that the same surface was exposed to the water over a period of time, which tends to happen when you use optical instruments, and you land up having data degradation over time. So how often should he go and validate against a third-party lab? That was costing him more. And so a good way to think of it, well, why will this solution work? One, we have over 9 patents, and we've built and created the system to be very modular to the customer, so that the mindset is almost of a platform as a service or data as a service, or almost you can think of when you're talking to your grower, you can talk about it as a measurement as a service, so that there is no capital budget allocated for the system for this monitoring. It's 100% service model where the service and the entire quarterly maintenance, if you may, is taken care of by a combination and a partnership with DRAM and us. And KETOS takes care of that service for every single customer of ours across the country. And we have a very distributed team that's capable of doing that. And from a calibration standpoint, we can address a variety of sources of water because we do a mechanism for self-calibration within the system. So whether it's river water, whether it's a runoff water, whether it's a groundwater, or even treated R water, or if you're in a vertical farming environment where you have a dosing tank and the water is actually used from that, then automated control of that dosing tank can also be done. So very excited about how the solution is working in the market. We've been deploying for over 3.5 years, since early 2017. The company has been around for the last 5 years, and we manufacture, build, test all of our instrumentation today in the US, in Wisconsin. So very excited about where KETOS Shield could grow, and also in terms of how much more it can be adopted within the farming community to drive a better impact. We'll leave the water efficiency piece out here, but we can always come back for questions on how that one makes an impact as well. So driving over, if someone thinks about, well, how am I going to access it? What do? We provide it as a service. We come in, we set up the systems, we set up the connectivity for you, and all you're worried about, you as a farmer, as a grower, or even as a service member, you're just thinking about, here's my login, here's my password. The customer owns the data, but we own the equipment. So it's a good way to think about, well, because I'm doing a service, do I own the data? I'm very sensitive to it. Of course, you own the data, and we're helping you derive a lot of those insights with that data. We're also working with a couple of satellite companies, just in case we're in an environment where there's absolutely no connectivity, no Ethernet network or no cellular, and there's also an opportunity to do that. So there are many options with connectivity, so I wouldn't be concerned if you're completely in an area that's 100% remote. I want to give you a quick example of this. So many of the farmer examples that I was mentioning, but this one was fundamentally, they chose us for these 4 reasons. One was they wanted to measure nitrates. They wanted to understand boron. Those 2 were kind of dictating factors. And they were spending extensive amount of time where they were going and grabbing a sample, prepping a sample, taking it to a lab, back and forth. So you have to think about, there's the lab cost of it, then there's the labor cost of it, and then there is there a guess estimate in the material? Can there be a potential savings on the material? So you've got a combination of lab, labor, and material that kind of encompasses all your operational costs. And then in addition, what's that value of an integrated data? And can I potentially increase my crop yield? Can this help me define my crop quality? Absolutely. So what we were able to do is we were able to dive in, of course, now this is dependent on how engaged the customer wants to be, but we were able to dive in and understand what's the topography of that farm. And can I take in that satellite image of that topography and look at the rainfall in that region, look at their soil micronutrients, look at specifically around their soil health. So I'm not looking at water quality data in a silo. Now, how do I combine that and provide a very predictive insight to that farmer in a very meaningful way that he cares about or she cares about, and not necessarily just giving them a pure water quality metric? And I think that's where you really increase the value of what data insights can do, and also what data-driven decision-making can do. So happy to answer a lot of questions on this as we come along to the Q&A part, but here's how a deployment would look like. When it's outdoors, we typically put it in one of these NEMA 4X cabinets and set it up such that, the customer doesn't have to worry about, do I have to build a separate shed? Or if you already have a shed, many customers tend to have a small water shed, and then we can just install the system inside. It just depends what the preference is and what they would like. We can install the system, get it set up, get the communication going, and pretty much after that, you're only concerned about what you're seeing on your mobile phone or your web platform. The system interacts. So for example, if you're sitting in Wisconsin today and your farm is in St. Louis, and you've got another one in Kansas that you're managing for 2 different customers, and you're doing managed services as an option, then you can basically set up on your cell phone and work towards, I want to schedule these X number of tests 3 times a day, or I want all these parameters once a day. Everything from your mobile phone for Kansas or for St. Louis or Wisconsin, depending on where you're setting up these, and do all of them remotely from your mobile phone. And that's the beauty of really engaging and being able to look at that data in a matter of minutes, and then figuring out, okay, what decisions do I have to make on my nutrients? Do I have to change anything? Should I change something in my fertilizer? Or everything looks okay, there's no spikes, there's no anomalies, and business can continue as usual, which is also a great sign. And the question is, sometimes you might have relationships with your labs and you have the lab data. So what I would tell my customers usually, don't hold that data back. What we can do is we can integrate the old PDFs, your logs, your old data. There are customers who've come to us saying, I have 10 years worth of data just in logs, and that's okay. It is what it is. So there is a value to collecting that data and integrating that into our platform, because now all the machine learning models and the AI for all the analytics we provide you is not limited just to the system that we're providing you, but it's now enabling also your old data that you could use, which can really improve our models. So I think there's a lot of value to taking multiple diverse sets of data and also looking at it as, how do I take the maximum power out of your data to empower you, versus only giving you net new sensor data. The more we think about interoperability, I think we can all work really well together in terms of benefiting the farmer at the end. So lastly, some of the thoughts here, you can have satellite imaging, you can have understanding of different types of metrics. I kind of briefly mentioned to you, but our platform is really interactive. So you can define your thresholds. So you can decide based on the crop you're growing, what is more important to you. You have all your analytics based on location. So you have location-based mapping. The alerts are defined based on the thresholds you set. So you can have the alerts go to your email, go to your mobile, or you can also have your alerts go to your maintenance system. We can integrate with your maintenance servicing system so that if someone basically were to use, your service and ticketing, they don't have to change their process. Our goal is to be a nucleus and be that glue connecting you with everything that you have, and not necessarily rip and replace or try to come in and change everything the way you do. So it's really about enhancing the way you do things today to make the most out of your day-to-day operations. All of this data is traditionally available, and also not every farmer has to do all of it. You can start small. You can start just with water quality monitoring. You can start building on the tiered analytics as you feel more and more comfortable, knowing that it's available, okay? Last but not the least, couple quick comments here. Ultimately, I think an intelligent water monitoring network is only going to empower you. So whether it's actionable real-time data, whether it's helping you with prescriptive maintenance, not just predictive maintenance, whether how much are you saving, and I would really encourage everyone to do an ROI exercise with DRAM and KETOS, and look at, how are you thinking about overall water grid management? And what if someone says, well, can I use a lot of my pressure data, my flow data, my irrigation data? Why not? How do you combine that data? And ultimately, is it moving the needle for me on the nutrient management front? That's another important question as well. So how do you combine all of this and look beyond just one parameter and one instrument? I think we're doing a disservice to ourselves if we still continue down the path of looking at every value of a water quality in silo or in a very isolated manner, or we're limiting ourselves just to the environmental parameters, or we're limiting ourselves to very expensive equipment. I think we need to think about models, especially in the current environment and beyond, where budgets are slashed. A lot of folks have lost their job and they're being very careful about how they are managing their entire expense. I think this is where OpEx models really thrive, where you can have a minimal, predictive, flat pricing for unlimited number of parameters, regardless of how much testing you do. It's one flat price that just lets you sleep at night, knowing just because you increased your testing or you have to get more consumable or you change something, your price is going to change. Your price doesn't change. It's a flat price model, no matter how often you test, how many parameters you test, or how many users are there on your system. And hopefully this was really useful, and I'm really excited to answer questions from here. And back to you, Kurt.
Thank you so much, Meena. I think you're fantastic talk, and I think everybody really related to it because we've got a lot of questions. So yeah, I think that was fantastic.
Probably way over time too, Kurt. Sorry about that.
That's not a problem. The good thing is we don't have like a room block that we have to vacate or something. This is the internet, and we can kind of let it go as long as we need to. So one of the early questions that came up, and you kind of went into it a little bit, but can you go over what types of things you can measure at this point? Specifically, someone asked about nutrients. Can you measure things like pathogens? What types of things can you measure?
No, excellent question. So today we measure environmentals, heavy metals, nutrients, and inorganics. So kind of putting them in these 4 buckets. So if I were to call out the parameters, I would say in the nutrients we do, today we do nitrates. And I had mentioned a customer also brought up phosphates. So we actually have released orthophosphates in Q2. So we can do phosphates. And so if you look at our full list, I would say pH, conductivity, TDS, salinity, DO temperature, a lot of the heavy metals, so lead, cadmium, arsenic, manganese. What we don't do is, there are a couple of things that I've seen from the ag community that we're yet to do, and that will be in our roadmap. Sulfates, so sulfates is still in a roadmap. And then pathogens is something, we've had very interesting feedback on microbial and bacterial, and as we're also looking at some COVID related testing on wastewater. So I would say think of it as a shield that will be there in the future for pathogens and viruses or microbial, and then a shield that kind of handles all your nutrients, microbial, like all your nutrients, your heavy metals and inorganics. They might be 2 different systems, just based on the level of scientific principles required for both are very, very different. But if a customer actually has a need, they usually give it to us so we can prioritize. Like right now, selenium, iron, mercury, zinc are basically in plans to come before the end of the year. And that will be available to every customer, regardless of which segment they come from.
Great. So another question that came up, you talked about it sounded like a lot of it was source water. In the horticultural industry, potentially recirculated water would also be a place where this could be employed, because the water is being captured and then tested, and then potentially fertilizer or other things would be added back to get it to the target levels.
Right.
Is that something that we envision for this system?
Absolutely. So we, when you think about recycled water, or yes, I was referring a lot to the groundwater and the source water aspects of it. But that being said, we are being looked at for even harsh waters like produced water. So where post-water reuse and post-water recycling, how is that getting handled after you're testing it? So there's one that's like the harshest of the harshest. And on the other side, I would say indoor farming, especially vertical farming, as it's picking up, that's another really important one as we're looking at treated water being used specific to crops and being very prescriptive about nutrients for different crops within a single indoor farm.
So another question that was asked that kind of connects to that is, how can this system maybe integrate with a controller? So I think what they're saying is, could you provide that data to, yes, say, an Argus control system that's developed, that's actually adjusting the levels of nutrients at, on real time?
Absolutely. And that's something so whether it's, sometimes people have a variable controller or whatever automated control system that you have, we would basically send that data to your control system via an API or integrate that with you, whatever is the preference, for you to then automatically have that nutrient management taken care of. So that's one way to do it. Second is, a lot of folks also tend to have some SCADA systems in place or other PLC systems in place, and we can send that data there too, whatever is the preference.
Okay, As I was going to say, the API model isn't necessarily going to work with most of the systems. There's some that are doing some online server-based setups, but most of it is all going to be hardware that is going to be pretty much resident in the customer's facility.
We can do both depending on what the preference is and what type of systems they have. And, you know, it's really just understanding kind of the interface of communication and being able to share that data to them.
So does the Shield have specific outputs on it besides just the link to the server?
We actually do. So for example, in certain industrial customers, we have to have it on their local network. So we actually have an Ethernet RJ45 port for them to plug into their own network. We also have a USB port depending on if there's another connectivity that's required from a data standpoint. But another way to look at it is also how we extract that data from the platform to provide it to your controls. Because then you actually have process data that is more meaningful to tie into the control system.
A question that came up is about the data that we do collect. So you mentioned that is not shared. It's the user owns the data, but do you share that as an aggregate to outside sources or anybody else?
We don't. So the way we use it is more from a modeling standpoint on the aggregate, but we do not actually, none of our data today is sold as or shared to any outside entity besides what the customer is actually using it for themselves.
We have a number of people actually online who are watching from outside of the US. So there's a couple questions that I'm kind of going to group together based on that. One of them is asking about, you know, the legality of owning and managing that property. So say you're putting the hardware outside of the US. Have you worked with other countries at this point? This customer specifically is asking the question from Central America. So is, you know, if the hardware was put in, is that, you know, what's the legality of owning that hardware?
Sure. So we've deployed, in general, KETOS has deployed instruments we've deployed systems in India, in Mexico, and the US. And actively now, I mean, depending on how these travel bans are lifted, we're going to be deploying both in Israel and Singapore later in the year or early next year, you know, based on logistics. And we're also actively engaged with customers in Australia as well as UK. So definitely pursuing internationally. We're trying to partner with the right strategic folks in the different regions. Because I think from a KETOS standpoint, we're a technology provider, we're a technologist, we provide the solution. We want to make sure that we partner with regional experts in different areas that we can really work with and collaborate in the local regional market. So if it's Central America, we are talking to someone who has a broad spectrum of coverage between Brazil, Argentina, and a few areas. So depending on where this individual is from, we can always figure out, is there a local partner we're already working with? Do they have a preference, and how would we engage?
Okay. From the same person, concerns about power. So what if there's no electricity? Are there solar options, other things, or is this really has to be plugged in?
Great question. It depends. So if you're doing kind of the continuous mode of operation, it does need to be plugged in for the level of data and the level of communication that's happening. We are working with a couple of aquifer type customers, which really don't have any power source where they are. So for those, I think if we're doing a frequency of, let's say, even once a day, where you're measuring all 20 plus parameters or how many ever range, and you have intermittent water for like 3 hours or something, then I think we're okay with solar. It'll keep it as a self-charge mechanism. We have to just work with the customer and putting that solar bank wherever they prefer and setting it up for the function. But it won't work for the capacity of doing continuous monitoring on a minute-by-minute basis and then having that kind of variance of testing. But you could still do like a scheduled test of all parameters once a day and still get great data and not have to drive 2 hours to a local, like a remote site, especially one of the problems we've had a lot of conversations with is Chile for the lithium ion mining that's happening with all the batteries, and they're really in the middle of nowhere. So figuring out how we put options has been kind of top of mind.
Great. One viewer has asked about the ability to deploy the shield into agricultural sector for parameters like soil moisture, weather monitoring, pest control. I think we kind of talked about that. This customer is asking about your plans in India, so it sounds like you've already done that.
Yeah, for India is really about, you know, what's the right fit, who's the right partner, how do we go in? But we are working with several parties in India, so happy to always have that conversation. Yeah, for sure. And we can do more. So we already collect soil health, we already collect rainfall, we collect topography, we collect this farm acreage along with their satellite imaging, and then layer on different vectors of our water quality. So there's a whole suite of parameters that go into our models, which make it more relevant to that farmer in terms of their own crop yield. So we do that data too.
I have a question. Again, another person from South America. The customer. I'm sorry.
You've got the international crew going today.
We do, yeah. These are all people who we know for the most part. But so this customer is asking about, are you planning to measure, or do you already measure silica?
Yes, we do. So we measured dissolved silica today.
Okay, great. And then I think the last one we have time for is, what is the percentage of error more or less for each of the main parameters that you're detecting? What's the plus or minus on it?
Great question. Where I would say a good comparison would be about plus or minus 10% to an ICP-MS system. So if you're used to a NELAC lab, which is what US calls them, or I would say a good metric is for the methods that are used in the lab to our EP compliant approach, we are about plus or minus 10% precision. So that would be a good metric to have.
Great. Well, there were a couple other questions, but I think we need to unfortunately cut this off because we have another webinar coming up. If you do have questions, you will get an email from us that will provide some email contact information. You can directly contact myself or Meena. Of course, as I said before, this webinar is being recorded and it'll be posted online very shortly. So if you want to share this with others, and if you have questions about the system, implementation, things like that, DRAM is early in the stages of working. Our goal is to start to implement this in horticulture. First, really by testing, we're starting to do some work to determine who needs what and where we can modify things. And we're just starting that phase right now, but we'd be happy to talk about solutions and where we could help each of you going forward. We're available throughout the rest of Cultivate on the virtual trade show floor. We've got a Zoom room open and everything else, so please feel free to join us there. And I really want to thank you, Meena, for a great presentation. I think everybody found it very informative, and I think it's a topic that we wanted to introduce because our industry isn't thinking this way yet, and I think they're quite honestly aren't really aware that this is possible yet. And so bringing it up and trying to introduce it, we thought was very important, and really easy to do this year with Cultivate being virtual, so we doing an online thing. So thank you very much.
Thank you very much for the opportunity. Really appreciate it. Have a great day, everyone. Take care.
Thanks.